Okay, we're looking at a second use of Pythagoras' theorem here, again to find some missing lengths, and it's very similar to the previous one, so one of the things we'll have to pay attention to later is not getting them mixed up. So you should remember that when we have a right-angled triangle with lengths, it's to do with Pythagoras' theorem, and Pythagoras' theorem, as you remember, hopefully, is to do with the area of squares, or at least the imagined area, the visualised area of squares sitting on the edges. So these triangles, we're all pretending that they've got a square stuck on them with some length, with some area we can work out from the length. And the area of this square we know is 8 squared, the area of this square we know is 10 squared. Now we know that's 64 and we know that's 100, but you don't necessarily need to do that. If it's a tricky number, just leave it written as a square. Now the theorem you learnt, or that you saw written down, was that. Now hopefully you can see that if I add these two areas together, it's clearly not going to be the area of a square here, because this square is smaller. So this piece of algebra we can rearrange using algebra, or we can just use our eyes and see that this is smaller. So adding won't work. The opposite of adding, as you should know algebraically, is subtraction. So this will be 10 squared take away 8 squared, or 100 take away 64. And that is 36. So the area of this square is 36 units, centimetre squares in fact. So to get the length, we will need to square root that. And as it happens, this is a whole number, this is 6. This is 6 centimetres. This is in fact the first example you've seen with whole numbers, and there's a whole bit of math you can look into as to which right-angled triangles you can do with integer lengths. They're called Pythagorean triples, and 6, 8, 10 is one of them. So, back to the actual topic, we can find a shorter length by subtraction. Now, here we worked out the areas and we did the subtraction and we did it all in steps. But just like with the previous video, we can do this in one go. We can just write down the subtraction and square root it. And if you can't do that in your head, your calculator can do all of that and will spit out 6. So depending on whether you've got a calculator or not, the different methods have different benefits. So moving over to the other triangle, I'll try and include it. We need to notice again whether this length we're trying to work out is more or less than what we've got. Now, I deliberately picked this peculiarly narrow triangle because it has a mistake some students make. Because this is quite long, much longer than this, students will want to add here sometimes, and I'm advising you to just pay attention. It's not always going to be that simple. Because this is even longer, so if we add something to this, it'll be longer than we start with, and this is clearly shorter than that. So to get shorter than this one, we're going to need to subtract again. I'll do this in the one-step way. So the key thing here is this length is shorter than that. It is not the longest. It doesn't matter if it's the shortest, it matters if it's the longest. And this is not the longest. So we're going to have that length there, but we need an area. We've got this length here, but we need it as an area, so we square it. And because this is shorter, we're going to subtract those. And because we don't want an area, we'll need to square root it. So that's the same shape as the previous work you've seen algebraically. So we put that through, square root of 164 squared, take 51 squared, and that is roughly 156. So this length here is 156 metres. So I've done some rounding there, because that's 55.8, but it's 156 metres. So when we're doing Pythagoras' theorem on right-angled triangles, and there's no other funny business going on in the question, the algebra always ends up being this straightforward. Look how similar these bits of algebra look. It's a square root of 2 squares. The only difference is that one's added and one's subtracted. And it's really simple to get them the right way around. If you need to get a longer length than you've got, if you need something longer than you've already got, add them together. If you don't need to get any longer, it's got to be subtraction. So when you add things, they get bigger. Sounds obvious, but sometimes it's made them made. And if you don't want to make them bigger, subtract them. And that's it. And as long as you remember that Pythagoras is about squares and the link between square length and square root, that will sort you out. So I hope that makes some sense. And I hope you can do some of the questions when they're set. Enjoy.